talk about this in a calculus way, then you would say the rate at which the amount changes, I'll use J for Joe's amount, J equals Joe's money. The rate at which his account changes is always the same, and therefore is a constant, K. Okay? What is that K? What is the rate at which it always changes? It's either a dollar or 10%, depending on the case may be. Now, in this case, because it's 10% of a dollar, it's always changing by $1. Wait. At any time. Now then, if you are to use good calculus to solve this differential equation, when you solve a differential equation, you're trying to go from the derivative back to the original. So what's the most important first step? Separate the variables. We talked yesterday about how in the AP grading scheme, if you don't separate the variables and show it, you'll learn nothing. All right. After that, how do you go from differentials or derivatives to regular? Integrate. Okay, so Joe equals, what's the antiderivative of 1 dt? 1 t plus, pick up a constant. Now, we integrated both sides, but we just put a constant on one side. Because it's arbitrary, we could put them together into one. You with me? We could use the initial condition. We know that at time 0, J has, or Joe has, $10. And therefore his, that C would be something like 10 equals 1 at time 0 plus C, so C is 10. Therefore we could say Joe's amount is, I can't seem to write a 10. 1t plus 10. What does that mean to you? 1t plus 10. Joe's amount is? Talk to me. Interpret, please. Use your brain.
Linear.
Linear. Okay. Describe the 1 and the 10. What do they mean? Starts at $10 and gets $1 every year. Okay? And that's linear growth. I appreciate that. When you have constant growth, it's always, no matter how much time, it's always going up the same. Right? Always going up by $1. Now that's not the most famous differential equation involved. The most famous differential equation is what we're going to get into over here. Say you did compound. Now we usually do compound continuously, but we'll do compound annually. If you started at 1 year, you earn 10% interest the first year, so that's $1. You end the year at 11. Okay? The whole idea of compounding you learned in pre-algebra is that Joe or Lou gets to say, hey, wait a second, stop giving me 10% on $10. My new balance is $11. So I want to earn 10% on $11. What is that? 1.1. So you would end the year with 11 plus 1.1, or $12.10, meaning he got an extra 10 cents in interest because he earned interest on his interest, right? That's how you get rich. Compound interest. 12.1. The next year. So the next year in interest, he'll earn $1.21. He'll earn $1.21 interest, meaning at the end of the third year, he would end with $13.31. And in that little bit of money, in that little bit of time, he had 31 cents extra on the other guy. Now, that's not a lot, but consider if it was $100,000, well, then you're really killing the other person, right? This is the big idea. In this case, you can say that the rate of change in the amount, the change in Lou's amount, I think we can agree is not constant. Interest is how much it's changing by, and that's definitely different each time. Why is it different each time? It's interest on interest. It's always 10% of a new amount. It's not 10% of the original amount, which is always the same. The original amount doesn't change. It's always 10% of the present amount. Now, this is the big idea then. It's when in exponential growth, the rate of change is proportional to how much there is in the account at any time. The rate at which it changes is directly related to how much you have. The more you have, the faster it changes. This is sometimes generally written in this way, which I don't much care for. We'll talk about that. Now, say we look at that and we do some calculus on that. The first thing I do is separate the variables. How would I separate the variable? First of all, is k a variable? No, k is a constant. Okay, so we need the d and the l together. I could do that by division. The k I could bring over, but I think in terms of ease, L is what I want to solve for. So the less stuff I bring over to the L side, I think the better. So I'm going to leave k over there and move the dt. Let's integrate. What's the antiderivative of 1 over L? Natural log of the absolute value of L equals kt plus c. Okay? Now, kt plus c, we could use the initial condition. The initial condition is at time equals 0, Lou has $10. Natural log of the absolute value of 10 equals k times 0 plus c. C is the natural log. I really wouldn't use the absolute value. 10 is already positive in that sense. You follow? So that puts me then, when I sub it back, into natural log of the absolute value of L equals kt plus the natural log of 10. Now our goal is to find the L equation. So let's talk algebra. How do I solve that equation for L? Exponentiate. So if I exponentiate, I have the absolute value of L equals e to the kt plus natural log of 10. I remind you, algebra rules are as when you exponentiate both sides, it's exponentiate a whole side, not a term by a term. That's very important. It's a very common error. When I take e to the side, it's the whole side, not term by term. Do you understand? You with me? Think of it like this way. This is important enough that I need to harp on it. Okay, do you agree that's true? Okay. Consider when you that's what I use. Consider when I take a power involved. If I square both sides, is it okay to say square here, square there, everywhere? Is that true? No, you just ruin the truth. 81 is not equal to 16 plus 25. If you square, you must square the whole side. Is that true? That's true. So you never do anything to term by term. That's math sin. Okay, you're going to ruin the problem doing that. So when I e this, it's not e this and e that separately. You cannot do that. Cool? Okay, what you can do is do a little rewrite here. My friends, I can simplify this if I could get e to just that one. But exponent rules. X to the 2 plus 3. What's that equivalent to in exponent rules? I know it's equal to x to the 5, obviously, but how can I break that up? X squared times x cubed. Isn't that the exponent rule? When you multiply two things with exponents, it's the same as the single with the sum, right? Now I'm going to use that, but in reverse. This is equal to e to the kt times e to the 11. Not plus, times. Now that's nice, because e to the natural log of 10 is just 10. And if I dump the absolute value, what happens when I dump the absolute value? It's plus or minus, and then it involves choosing, but I know because at time 0, L is positive 10, we choose the positive, right? L doesn't have, or Lou doesn't have negative money in his account. It's positive 10 e to the kt. Now, the big idea then, hopefully I didn't get this lost in the shuffle then, is this differential equation, the rate changes at a rate proportional. That's where exponential growth equation comes from. It comes from that idea, proportional to the calculus idea. So if you are to ever be given the idea, you really need to understand this on 3 levels. The verbal description. If they say the amount changes at a rate proportional to the amount, it's kind of wordy. You know, you need to be able to understand what that means. If they say the amount changes at a rate, that's a derivative, proportional to the amount, or directly related to the amount, then that's interpreted into that differential equation. But if we separate the variables and integrate, where that actually ends up is more like the exponential growth equation. The amount is equal to the initial amount times the growth factor e to the kt. The amount equation for exponential growth. Or decay. Decay. Now we would, in pre-calculus books, we would expect the problem to be worded, the amount grows exponentially. That tells us it's an exponential growth equation. I use this equation. In calculus, they wouldn't say the amount grows exponentially. They would say the amount changes at a rate proportional to the amount. That's for you to know that that means this, and that leads to that. So on an AP multiple choice problem, which on this first one I stripped away the answers to, it says bacteria in a certain culture increases at a rate proportional to the number present. The number of blah, 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 every 4 hours. How many hours till it triples? To get into the problem, you need to take this sentence and know that that means exponential growth. And so I know this is what's being implied. And then you do your pre-calc, exponential skill. The number of that doubles every 4 hours. That's a case being given to you. It's not a very obvious case, but it's a case. That would tell you that after time, the amount is 2 A initial. Doubles, right? And the time is 4. From that, you could find your K. K is, well, I imagine you could probably do that all in one. That's log of 2 divided by 4. Right? Do you agree? Okay, so now I have a complete amount, or a complete equation. I don't really know the initial amount, but I don't really care. To answer the question, how many hours till the bacteria triples? Well, that would be the question. So the question, now that I know K, how would I get into that? What would I put into our big equation? Triples would imply I want to know when the amount is 3A initial. 3A initial equals A initial e to the K we know. I'm just going to call it K, though K is right there. And T is the question. So how would I solve this? I'm solving it for T. Natural log of 3 divided by my K. Obviously, it would take more than 4 hours. If I got any number that wasn't 4 hours, bigger than 4 hours, I did something wrong, because I know it doubles in 4 hours, so a triple should take more time, right? You with me? Okay. Interest of time, are we doing okay? Would you try this one on your, see what you think, please. You may just calculate it. this exponential growth or decay? If it's decay, what do you know about K? Negative. Oh, that is the question. Thought they're asking about a third case. So I don't know which one is equal to natural. I go 2/3 over 16. Okay. Do we all agree? Okay. Yes.
Is it okay to use like differentials instead of that equation?
So if you, so did you, what do you mean? Did you work in this equation and separate the variables and?
Yeah.
Okay. Yes. In terms of time on the AP test, I think they're expecting you to bypass that. Now, if they gave you on a free response question the differential equation, then you would be expected to show all that work. And so it's good practice. But on a multiple choice, I think it's more expedient to just say, I understand this means exponential, go straight there. Okay? Your question. Okay. Questions on last night's homework? Okay. Set 88. 3, 8. Did I do that right? 3 and 8?
3 and the replacement.
3 in the replacement.
4, 26.
Man, I mean, 8, 3, the replacement. 24.
Four was also a replacement.
4 was? Okay. Was it? Oh, yeah, that's right. Okay. Unfortunately, I apologize, but I haven't done them yet, so I'll do them now. No slacker, yeah, sorry. How to do the last one?
Yeah.
Sure.
Yeah, the last one.
Okay, so let's start with just like the last one. So let me start with the last one real quick, and then we'll go backwards, just because. So you have the square root function and a slow-growing linear function. I am fine if you just guess and check that they meet at 4, 2. I believe that to be true. Are you with me so far? Okay. If you revolve this around the x-axis using x, then what kind of approach? Or what kind of, that's important that you, it's a washer, okay? It's important that you show a slice revolve. The whole region not so important, but a slice revolve very important. So the setup should be pi. You're good on that one. Okay. Will somebody throw out the answer to that?
I got 8 pi over 3 for that one, but I got 8 pi over 5 for
Okay, that is a problem. Okay, let's focus on B and see which answer is right then. So if I do the same region and I revolve around the x-axis using y, let's start with the y slice. Y slices go this way. That's obviously important that you understand that. The revolution of such a slice makes a very thin empty cylinder, which is called a cylindrical shell. When you cut it and unwrap it, it's usually along the side. And so we'd unwrap it this way and it would be long this way. This distance around the circle would become the height of that, it'll be the circumference. This distance here will correspond to, I'll call that h, for lack of a better word, and this thickness is super thin, it's dy thick. So, we need to identify R and H. R, here's R, the distance to the circle, or in this case, it would be here. What do you notice about each of those R's? It's X or Y. That's a vertical distance, right? Isn't that the distance up to 2 or 3 or so on? So isn't that the Y? Okay, so the radius is Y. This component here, the height, is a horizontal distance. It's the line minus the curve, and then we just decide in what terms, X or Y. Y terms, all right? So we're looking at this height component being the line minus the curve in Y terms, so maybe 2Y minus Y squared. Wait. If I then set up the integral, it's 2 pi from 0 to 2, because that's the Y limits of integration. Y times 2Y minus Y squared. That's 2 pi times the integral of 2y squared minus y to the third squared dy. So here we go, 2 pi 2/3 y cubed minus 1/4 y to the 4th, 0 to 2, 2 pi, 16/3 minus 16/4. 2 pi, let's go 16/3 minus 4th, the common denominator would be 12/3. So I'm feeling 8 pi over 3. So did you get that one right and the other one? Which one did you miss?
I missed part B.
B.
That's what we just did.
Okay, so you cool? Okay. Okay then, did that answer your question?
Yeah.
Okay, you bet. Okay, find a time if any of the particle passes through 0. We actually could go through several times, but I just asked for one. Does the particle have to pass through 0? Oh, that's a stupid question.
Yeah, it was good.
Maybe it would have been. That is what it is, whatever. Okay, sure. We'll check your vision. Yes, at time 0, x equals 0, according to the table. Used vision. Okay? That was not my intention, my bad.
Well, it's not the one between 1 and 2. It's what confused me.
Here? Yeah, so maybe that was my intention. Maybe I just should have said time where it passes through x equal 2 or something.
Not to mention you never said that it was continuous.
Good question.
So
Oh, position. Okay, so position you can imply. It is implied. Because, well, actually, don't get through your physics on me, okay? But we assume that when you go from one position to the other, it's continuously through that. Don't give me your quark moving this away. Okay, it's beyond me. Okay, let's assume we assume in calculus assume position is continuous. Okay, find a time if any of the particle is at rest. We don't have the velocity. I think we all agree that that means velocity is 0, not moving, right? Velocity is the same as x prime, or the change in position with time. So we need to say, is there some instant where the position's not changing? I would first look for, is there any case where there's identical x's where I'm right back to where I started? And there weren't any such cases, right? So that's what makes this problem a little yuckier. Does that mean that it wasn't ever at rest? Okay, just in terms of a real loose argument, in this case it seems like it's moving left, and now it's moving right. Well, could it have gone from moving left to moving right without having stopped instantaneously? It must have it's been at some point stopped. The hard part, though, is to show that. It would go something like this. Position is continuous and differentiable. So by MVT, there is a time, I'll call it T1 in 0 to 1, where x prime or v at that T1 is equal to x at 1 minus x at 0 over 1 minus 0. The velocity, average velocity on that first interval was negative 7 over 1. And so there must have been an instant where he was going negative 7 units per time unit. Similarly, there is a time 2, and you could go any of these subintervals, but I'll just go 1 to 2, where x prime or v at that time is equal to the average change in position over that time interval, which is a positive 1/15 over 1. Right? Now, we just showed that velocity at one instant was negative 7, at another instant was positive 15. Could it have gone from negative 7 to positive 15 without having been 0 in between? No. And so you then say velocity is continuous. So by IVT, actually I should say the between is, velocity is continuous and v equals 0 is between negative 7 and positive 15. So there must have been a time when velocity was 0. You follow? That was tough. Those happen every 3 or 4 years on the AP test, so hopefully you'll get lucky and not have to do that much writing, but you never know. This one, the Shells one. I hope that you are able to factor out a greatest common factor and then factor to see what the graph looked like. This is a cube that bumps 2. So the graph should look like that. If you revolve this around the y-axis, then it would look like that, a bundt cake kind of shape. But the point is that you definitely don't want to use y, because solving this equation for x in terms of y is a non-starter. It's just not going to happen. You've got to use x. And so what happens if you use an x slice in such a case that's around the y-axis? You have to use a shell. So we're going to go shell. This distance is the circumference. This is the height. 2 pi. What's the radius? It's different each time, but it's a horizontal distance, so it's just here or here. Isn't that just the x at any point, yeah? So the radius is x. What's the height of each of these? It's just a function x cubed minus 4x squared plus 4x, right? And the limits of integration are from 0 to 2, whatever that is. Oh man, maybe I should have just said set up the volume. Whatever, you can integrate from there, it's not too bad. Okay, how about 20, oh, these were, do we need 8 and 3 still?
Yeah, I need, yeah, I need 8.
Okay.
Yeah, like,
9 seconds? That does make it difficult. 8, I can tell you the best thing would be to say dy dx is 3 times x.
Hannah Jordan and Sean Conrad, please report to attendance.
I'm not sure what's room. 3, I'd use x in shells.
thank you.
You're welcome. Have a great day. Okay.
I guess someone else beginning of September.
When I'm done, I'm fine.